Hey class, here I go again. Today what I'm going to do is I'm going to show you guys how to do the identification of unknown liquid lab, okay? That's this guy right here. Okay? Then your lab manual says this, that's number 3 right there. Now the thing is that the objective of this particular lab is to try to use a physical, you'll be given a clear liquid, and what we're going to do is we're going to use this physical property to try to figure out what that liquid is. Okay? Now, the thing is that what is a physical property? Physical properties are characteristics of a substance that describes how it interacts with its environment without changing composition. Okay? And there are quite a few of those. Now, however, today we're going to utilize 3 of those. One is the thing is that these are the possible liquids. That's on page 18 in your lab manual. It's one of these guys, okay? And then, of course, we're going to use the boiling point, density, and as well as the index of refraction to try to determine what that substance is. And what we're going to do is going to measure them. And, of course, what happens is that you have a substance that have several matches for the property. That would be the most likely substance, okay? Now here's one thing I need to tell you guys. Let's see, the density, your number will be slightly lower than what's written here, because what happened is it says for 20 degrees Celsius. Typically here in Phoenix in our lab, we're about say 25 to 27 degrees Celsius. So therefore, since a higher temperature, the volume expands, therefore, see, density is equal to mass by volume, so since the volume expands, you expect your density to be lower than what's said here, okay? The other thing is this, the index of the boiling point. What happened is that this is recorded for sea level. Now, what happened is that here in Phoenix, we're about say 1,100 or 1,200 feet above sea level. So in that case, since there's less air above us and less pressure pushing down on the liquid, it's easier for it to escape. So therefore you expect that the boiling point of your liquid to be slightly lower than what's listed here. Okay, like say for example here, they say that the boiling point for water, that's a normal boiling point, that's for 1 atmosphere. Sea level is 100 degrees Celsius. But typically here in Phoenix, it's about say 98 degrees Celsius because we're on a higher elevation. Okay, so therefore you expect your boiling point to be lower. And then also the index of refraction is such that this is also for 20 degrees. Now what happened is that when we use the refractometer, it'll give you a temperature as well as index of refraction. And you'll be using a certain formula to correct that. And that is shown on page 17, right there. Now, if you use these 2 equations in these examples, it'll give you the correct methodology as well as the correct number of sig figs, okay? Anyway, hint. Anyway, I'll show you guys how to do the experiment in just a moment. All right, class, here's the equipment that we're going to be doing. These are the equipment and the samples we're going to do. First thing is that go over and grab a sample. The sample is a test tube with a black cap, and there's a number on that thing. Make sure you write down that number on your lab report, okay? What happens is your teacher will know the identity and will compare. All right, the next thing is that you should have a dry 10.00 milliliter volumetric pipette, a pipette pump, okay? And then here's the thing, you need a 250 milliliter flask with a stopper. Hey, it's critical that you have a stopper on this because the liquid that we're using this time is volatile, meaning it would readily evaporate. And that if you don't have a stopper on it, when you put it on an analytical balance, the mass will drift down uncontrollably. That's because the liquid is evaporating as you're weighing, okay? So therefore it's like that. And then you should have 1 or 2 boiling chips, okay? Boiling chips. Now, what we got over here is that this is for the density, and then we'll reserve this one right here later on for the index of refraction, that sample, okay? Now, for the boiling point determination, you'll need the following. You have a pole right here, here's a clamp. Go get a hot plate, okay? A hot plate, a 250 milliliter beaker for putting this tap water for boiling, and then you also have a boiling point apparatus which consists of a large test tube. And then what happens here, you have a rubber stopper with a thermometer, an elbow with a hose. There's your boiling point apparatus, okay? I'll mount it back here, like that. Stick it back in here. And then, hey, one other thing. make sure that you know where the waste container is. This time, what happens, do not throw this stuff into the sink, okay? You typically, in the lab, they'll provide an organic waste container. All of your waste will go in there today by the end of lab, okay? Never down the sink. Making sense? All right, very good then. All right, class. What I'm going to do is this. I'm going to show you guys how to do the density part of this experiment first. And then I'll show you guys how to do the boiling point next. And then we'll show the index of refraction, okay? So what you need to do is this. First thing is to go and get the empty flask with the stopper. And what you want to do is weigh it, okay? So in that case, zero the balance, open up the door, park it into the balance, close the door, and then record that mass, okay? There's your mass of the empty flask with the stopper, okay? Put that in your lab manual. Next thing, take that back out. And then what you need to do is that you need to go and draw the sample. Now, this technique is a little bit harder than that in the density lab, in the sense that you have to put it in, and of course, as you're drawing, you have to go down, okay? Because you don't want to just stick it in there, although it'll splash out. That's Archimedes' principle. So, make sure everything's down and prepped. Then what you want to do is say, hey, you guys, make sure that whoever hand's holding the test tube has a glove on. You don't want that stuff absorbed through, okay? So, here we go. Like this. Put the tip in. And what you do is use a wheel to draw up the liquid. Okay? Like that. Draw it up as you're going down. And go past that line. There's that particular line that's on the pipette. I want you to just draw it, put it above the liquid, and then dial it back down to that particular line. There it is. Okay? Then what you then do is go and open up the flask, take the stopper off. Then what you then do is put it into the flask, push the button, yes, and it'll dispense. Hold both, okay? And of course the last bit is also touch the pipette to the flask, that we get all the liquid out. Put that down. Close your sample. Put the stopper back onto the flask. Okay? Got it? So put the stopper back on the flask. Now you got a flask with the liquid in it with a stopper. Then come to the analytical balance again. Make sure you zero the balance. Open the door. Park that in there. Weigh it. And what happens is that the mass is stable, because what happens, none of the liquid is escaping, the stopper is stopping it, yeah? So therefore, record that. Now in that case, hey, you're done with the density part of this thing, yeah? All right, now what you then do is this, reserve this portion for the index of refraction part of the experiment, okay? So therefore, leave that alone. All right, proceed to the next step. All right, class, now that we finish up the density part of the lab, let's do the boiling point. Okay, so what happens is, like I said, we have a hot plate, 250 milliliter beaker, that boiling point apparatus, the remainder of that sample, and boiling chair. Okay? Now, hey guys, precaution. See it right there? Before you start, what happens is that never plug in until you're totally set up, okay? Because what happens is that this is a safety measure. You do not want to get accidentally burnt while you're setting things up. And then the other thing is this. See the hose? It should dip into the sink, because you do not want to be breathing that stuff. It'll be coming out through it, yeah? So all the exhaust will go into the sink and not coming out at you. And then the third safety precaution is this. See that white top right there? That can be potentially very hot. Never ever touch that, because you can get a second or third degree burn touching that. And of course, you have a glove, that would suck when you have a mounted glove on your hand, yeah? So therefore, unplug, don't turn anything, let's prep, yeah? So, what do? First thing, let's take this guy off, the boiling point apparatus, take that off. Now what you want to do is that beaker right there, I'm going to fill it about, say, a third full, maybe a third full of tap water. Okay, don't waste the still water on that. So here we go. You don't want too much water because what happens, the more water you got in there, the longer it takes to boil. So park that here. And then next thing is this. Take apart the boiling point apparatus. And what you want to do is to go and pinch out 2 or 3 boiling chips. Okay? Park it in there. All right? Then, you know the remainder of that liquid? Hey, you guys, it doesn't matter how much you got in there, okay? Because this is an intensive physical property, meaning it doesn't matter how much stuff you got in there. So, here we go. You already got a portion from the density go to index of refraction. This one right here, just pour it all into here. Yeah? There we go. Close that. Then what you want to do is this. Put the rubber stopper on. Hey, you guys, precaution. Hold it by the rubber stopper. And what you want to do is push in and twist holding the rubber stopper. Don't grab the elbow or the thermometer because what happens if that breaks, it'll cut your hands. Understand? So therefore, there's that. Okay? So hold the rubber stopper, push and twist. Next thing, mount it onto the clamp. Now, here's the thing. You want to lower it such that the water level is higher than the liquid but below the thermometer, okay? Let me repeat. The one in the book, I messed up a bit. I drew it in the wrong manner. Since that the water level should be higher than the liquid but below the thermometer. So in that case, here we go. Like that. And let's see. Clamp that on. And in my case, I have to lower it just a tad bit. There we go. Okay? All right. Now that you got this thing set up, so make sure it's still unplugged. Nothing's turned. Make sure that hose is hanging into the sink. Now what you want to do is this. Well, it's still pointed this way. Now the thing is this. What happened is that on the hot plate, the left knob is the one you want to play with. That is the one that is for heating. The one on the right is for stirring. We don't want to play with that one. Okay, so here we go. Now that everything's set up, I can plug it in. So therefore, electrical plug in. So never plug it in until you've got everything totally set up. Okay? All right. Now that's plugged in, what you then do is that the left knob, okay, see it better? So that left knob, what you do is that turn it all the way clockwise. And then you'll get a green light right there, yeah? That tells you it's on. So from now on, do not touch the white spot, okay? Now it's going to take several minutes to boil. So what I'm going to do is this. For now, I'm going to pause the video, the time elapse, and then we'll come back when it boils and I'll show you. This was a time elapse video. So what happens, I didn't want to watch you guys watch water boil. That takes forever. Now what happens at this point, it is boiling. So what you got right here is that the water's boiling, and if you look inside, what happens is that the liquid is fizzing in there. This liquid is fizzing in there. And then what happens is that you see gurgling right there. See the liquid's going back and forth like that? That tells you that you have both a liquid on the bottom as well as a vapor on top. So once you have the coexistence of the two, the temperature is steady. In that case, what you then do, go read the thermometer. And in this case, it is, well, whatever. Okay? Now, so therefore, make sure that the inside of the liquid, it fizzes. And then what happens, there's gurgling, okay? And then the temperature is steady. So once you've done that, then, hey, you're done. In that case, shut this baby down. And then proceed to the refractometer, okay? All right, class. Let me show you guys how to use the refractometer, okay? So what happened is that you got your liquid that was in that flask from the density part, yeah? Bring it over here to the refractometer. Now what you got over here is that the sample chamber is right there. There's a window. You're gonna pour the liquid on top of there. Now typically in my class, I do it. But however, your teacher insists that's how you would do this. All right, so therefore there's the sample chamber. This is the wheel. Now the thing is, the big wheel and the small wheel is the same thing. Big hand, small hand, okay? And basically what you guys are gonna do is you're gonna pour the liquid in here and then close it. And you're gonna park your eyes right there. And what happens, you'll see an image that there's a black and white interface. That's black on the bottom, white on top, and then there's a crosshair. And what you guys are going to do is you're going to turn until the black and white interface hits the center of the X, so that you turn the X into a V. Got it? And then after that, then what happens, you push the button read. And it'll give you the index of refraction at that temperature plus the temperature. Okay? It's relatively simple. So this is what you do. Get a piece of Kim white. And what you want to do is that kind of dab. Then what you then do is this. Hey guys, don't breathe this. So open this. And what you do is pour a little bit onto that window. Just enough to cover it. Okay. And then what you then just close this door and squeeze all the bubble out of it. Okay, you'll see it. And then once that's done, hey guys, make sure you guys park it back in. And then what you then do is look down. And what you want to do is that you're going to turn this knob until that X turns to a V with the black on the bottom and white on top. Okay? So what you then do is like that. All right, there we go. Can't quite show you the image because what happens, the camera won't look in. I'll go on the board and tell you what it should look like. All right, and then once you have aligned it like that, now what you then do is push read. It'll take maybe a few seconds. There it is. It'll read the index refraction on top, 1 point blah, 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 blah. And then the bottom one, it says 25.14 degrees Celsius, whatever. Now your sample might be the numbers will be different, okay? Hey, you're done, yeah? Now what you want to do is this though. Don't leave it like that. What you want to do is get the Kim white, and what you want to do is that dry up the metal block as far as dab. Don't rub the window, okay? Dab the window dry. Okay, close that back down. Hey, so therefore what you do is record the index refraction as well as the temperature for your sample. Now your teacher should have put the index refraction and the temperature for the water as a reference, okay? So make sure you get both before you go home. So in that case, hey, you're done with this part. So therefore, go back to your station with your flask and clean up. All right, class. Hey, I got used to the board because what happened is that the camera couldn't look into the scope. So what happened is that when you look through that scope, what you'll see initially is something that looks like this. Initially, you'll see there's a dark black kind of area, then there's a white area right there, and this is what I call the interface. And then there's an X, the crosshair. Now what you do is that you turn the knob ever so gently, either way, until you get that interface to hit the center of the X. So you turn the X into a V, yeah? So once you have done that, then what it tells the refractometer is that that's a correct reading. That's when you're going to push, yeah? That's how you do that.